This is the University of St. Lucia College of Arts and Sciences Mathematics Department. This is our video lectures for Algebra 101. This is actually our fourth video now. And in this video, we're going to talk about another selected topic under functions, that is function notation or functional notation. Okay, function notation just simply says that y is equal to f of x. If you can remember from our previous video that a relation is a set of ordered pairs, x and y. Here, we just say that y, our output value, is just equal to f of x, meaning you could just equate that. In this functional notation, instead of writing our output value, our set, you know the y as our set of range, instead of writing it as y, we're going to write it as f of x. So if we're using equations to represent functions such as say this one, we can state that f of x is equal to 2x plus 1, where x is the independent variable, our input value. So it's called independent because that is where we input, that is where we substitute values there. Okay, so we input values there, and our y is the independent variable or our output value. Why is it called dependent rather? Okay, why is it called the dependent variable? Because our y or our f of x in this matter just depends on the value of what we are inputting in our independent value, what we are plugging in our x value. So actually it just waits there. That's why it's dependent on our input value. So it's our output value. So hence we can say that y equals 2x plus 1 can also be written as f of x equals 2x plus 1. Okay, again, x is the independent variable, y is our dependent variable. Sorry for that one. Okay, so one important application of this functional notation or function notation is when we are evaluating functions. That is, we are substituting values on our equations. Okay, so simply as substitution. So our common way of saying this is substituting it. So evaluating functions means finding the value of f of x. So we're finding the value of our output value here. For example, what is the value of the function f of x equals 2x plus 1 if our x is equal to 5? So we have chosen our x here, our independent variable, as x. So what we're going to do is to substitute or plug in this x equals 5 in this our equation here. So what is the value of f of x? F of x is equal to what if x is plugged in into 5? So we can imagine it. If x is equal to 5, so we can input x as 5 here. So we could restate this as 2 instead of x. 2 times 5. Well, 2 times 5 is 10 plus 1 is 11. Therefore, the value of our f of x is equal to 11. So we could state here in a linear form, f of x is equal to 2x plus 1. So again, x is equal to 5. So 2 times 5 plus 1. 2 times 5 is 10. Plus 1 is equal to 11. So thus, our f of 5 is equal to 11. So we could write it as this actually. So since our x was changed to 5, so instead of writing x, we could state 5 here. So our f of 5 is 11. One more important thing before we move on. F of x is a notation. Okay, so it's a function notation. We are not multiplying f and x here. Okay, f is actually the name of the function. So f could be changed. The most common is just f in most textbooks because it stands for function. Well, but it's only a name. We could change the f of x, okay, into a different name. But the important thing here, we're not multiplying f and x. Okay, it's a notation. So if our x is 5, so what is the value of our equation? So f of 5, okay, the function here, if x is equal to 5, is equal to 11. Okay, hopefully you got it right. Now, one more example. Again, like I said, f is just a name. So we can change that as g. Or you could make it h, or I, or j, or k, or z, or whatever. Okay, so the f here is just a name. So I'm going to change it in this second example. G of x is equal to x squared plus 2x plus 1. So we are asked to evaluate, that is, plug in, substitute, at x equals 2. So which means we're just going to substitute all the x's here by 2. Okay, so imagine this x here will become 2, this x here will become 2, there's no x here, so leave it be. So we can say 2 squared, it's going to give us 4. 2 times 2, it's also going to give us 4. So 4, okay, plus 4 plus 1, well, that will give us 9. Okay, so we have g of x equals x squared plus 2x plus 1. This is our original one. So substituting all the x by 2 as given here. So 2 squared plus 2 times 2 plus 1. That's going to give us 4 plus 4 plus 1. That's going to give us 9. Okay, so we can see that g of 2, again, we change our x as 2. So therefore, g of 2 is equal to 9. Okay, that's how we evaluate functions. So again, we are simply substituting and then following the rules in algebra, the PEMDAS especially, the PEMDAS or the GEMDAS in some textbooks, like, groupings, exponents, multiplying and dividing, addition and subtracting, that. Okay, so before we end in this video, I'm going to give you some exercise. Okay, we will evaluate each function when x is equal to -1 or to -1. We will evaluate it, substitute it by -1 of all the x's in our functions given here. We will try to answer this in our next video. Okay, so try to pause and then answer it on a piece of paper, on your notebook. So we can see for letter A, f of x is equal to x cubed minus 1. So what's the value of this f of x if x is equal to -1? G of x is equal to the absolute value of x minus 2. Okay, if you can remember the absolute value bars, everything inside this grouping will become positive, so no matter what. Okay, so what's the value of g of -1? And lastly, h of x is equal to the square root of quantity 3 plus x squared. So substitute the x here by -1, and then what's the value of our square root? Okay, that's our h of -1. Okay, you can pause the video, or you could just have a screenshot of it and then try to answer it on a piece of paper, and then we're going to answer it in the next video. Okay, thank you so much for watching. Hope you get something from this lesson, function notation. Actually, our next lesson is evaluation of functions, and we're going to have our emphasis on this exercise. Okay, kindly don't forget to subscribe and hit the like button. We're also on Facebook. Here's our link, and that's it. Thank you so much for watching. Goodbye.